So what is the relationship that exists between the Newton's second law of motion as well as the linear momentum? So that's the essence behind this video. Just have to stay active and keep on focus. Let's say we have the object. Let's say this is the object of, let's say, a mass A, and say the object has been subjected to the forces. Let's say the force given as F has been subjected to, or actually has been subjected onto the object in that way. Let's say initially the object is having the initial velocity given as u. Now, since the force has been subjected onto the object, now the object has accelerated up to this point. Let's say now the object now should have it in this way. Let's say the object now is at this point, and now with the final velocity given as, let's say, v. And let's say the time takes from this point to this point, while the object has been subjected to the force. Let's say it is given as, let's say, t. So for this case, since there is a change in actually velocity, it means the object accelerated up to the extent that the acceleration is given as this case, and towards the direction of the motion. So according to the Newton's second law of motion, what is the force responsible for the acceleration of the object? So now the force is given as the mass times acceleration, and where this is the mass in kgs, this is acceleration in meters per second square, and the force literally is given in newtons. So take note of that. But what is the acceleration? Acceleration is given as v minus u over time. So in this case, we'll have force is equal to mass in times acceleration, which is v minus u, and divide by t. So now of which you have the force being given as mv minus mu divided by time. And guess what? This is how you should have it. You understand that v minus u, this is the change in velocity. So that is the final velocity, this is the initial velocity. And that you can have it in this case. V minus u is the change in velocity. That is the final velocity minus the initial velocity. And we know that the product of mass and the velocity is said to be the momentum. Hence, this is now change in momentum. We have the final momentum, and this is the initial momentum. So take note of that. So which means we'll have force being given as the change in momentum divided by the time. Now the force can be defined as the rate of change of momentum per unit time based on actually this relationship. And that is the change in the momentum is equal to mv minus mu. So take note of that. So which means if we have the change in momentum and have the time, can be able to have the force using that formula. And let's say we have the force and the change of momentum, can be able to have the time using that formula as well. So take note of that. And now let's think of having the cross multiplication. So now in this case, we'll have now ft is equal to mv minus mu. So what is ft? Now ft is what you call impulse. So ft is said to be an impulse. So this is the very important parameter or a quantity in physics, that is an impulse. So what is an impulse? Now this is the product of the actual force and actually a time. So that is the product of the force as well as the time. And basically it is given in newtons, newton meter. It should be newton second. That is an impulse. That is the product of force as well as the time. And another explanation, actually another definition for the impulse can be given as this. So impulse can also be defined as a force applied to an object for a certain amount of time. That is also another definition of impulse, and it is symbolized as actually I, and it is an example of the vector quantity, as it consists with the magnitude as well as the direction. So that is, so now as you can see, which means the impulse will now be given as, impulse is given as Ft, and which is also the same as mv minus u, so which is the change in actually a momentum. So which means the impulse can also be defined as the change in actually a momentum. So impulse is the same as the change in momentum. So that's how the Newton's second law of motion and that of a momentum actually are related. So take note of that. So now how can we be able to write some questions now for this actually a concept? So now let's say we have this question. A force A has a magnitude of F. So we have a force A with a magnitude of F, actually a force F, and acts for the time. Now with respect to the time, that is a time for force A being given as, should be, let's say, a change in time. Well, let's say just have to say it as a time. And for force B has a magnitude of 2F. Now we have a force given as FB, and the magnitude is given as 2F. And what is its time? That is a time for force B, that is TB. We'll have it as, now we'll have it as D/3. And we have the force C. What is the force C? It has a magnitude of, let's say, 5F. So which means the forces are increasing from F, a single F, 2 times force and 5 times of actually force, which means the forces are increasing, as you can see. So what is the time for C? That is TC. So have it as D/10. So it should be should be 10. That's what we have. Then next we also have the force D. That is FD. What is the force D? It is given as the 100F. And what is its time? Let's say a TD. A TD is given as D/100. So now the question says that rank these forces in order of increasing impulse. So which means we need to have, let's say, the impulse for force A. We need to have the impulse for, let's say, a force B. We need to have the impulse for force C, and we need to have the impulse for a force D. And check, check which force is giving us the highest impulse. Then we should have to arrange them in increasing order. So try to have this problem out at your own time and check it out. Of course, you'll be able to have the impulse using the formula, that is the force times time. So try to check the one with the highest actually impulse. Then can you try to check the one, actually the one with the highest impulse, lowest, and keep on having that range. Of course, you have to start from lowest up to the actually highest. So try to have their respective actual impulses, and you should have to arrange them in ascending order. So try to have that one out. Now how about this question? Find the magnitude of the impulse. So we're looking for the impulse now, so that we don't know. And deliver to a soccer ball when a player kicks it with a force of, now we have the force given as actually 1250 newtons, that is. And assume that the player's foot is in contact with the ball for about the time given us 5.95 times 10 to the power should be positive 3. Here should be positive 3 seconds. So what is the impulse? Now the impulse will be obtained you actually using the formula given as ft. So try to have the impulse there. And now let's consider this question. A 0.45 kg, now that is the mass. 0.45 kg. Actually a croquet ball is initially at rest, so it means the initial velocity is 0 on the glass. Now when the ball is struck by a merit, the average force, now we have it as a force, and exerted on it is 270 newtons. So now if the ball's speed after being struck is a 5.4 meters per second, that is the final velocity, should be 5.4 meters per second. Now for what amount of time? That is the time we're looking for. So for what amount of time was the merit in contact with the ball? So how should you be able to have the time there? So use the formula which is given as the force is equal mv minus mu divided by time. So try to have the time there, and since we have the initial velocity actually as well as the time velocity, and also we have the mass, you can be able to have a time in that way, in much as we have also the force. And now finally let's have to look at this question. When you're spiking a volleyball, a player changes the velocity of the ball from now initial velocity 4.2 meters per second to now that's the final velocity given as 24 meters per second along a certain direction. If the impulse derived to the body actually to the ball by the player is 9.3 kg meter per second, now that is the impulse, 9.3 kg meter per second. Now it should be that. Now what is the mass of the variable? So now we are looking for the mass of the ball, actually of the variable. How should you have the mass in that way if this is the case? So we know that the impulse is given as the mv minus mu. So we have the impulse, then we have the final velocity as well as the initial velocity. Can be able to have the mass using this formula. So that is, so try to go through a lot of examples or practical questions you can have to come across with, and for actually this case. So thank you.